Hi guys, getting going on some logic in 2.2. Before we get going with that though, I want to do some definitions with you. A statement is a sentence, and that sentence does not have to be true. It could either be true or false. So any sentence whatsoever could be a statement. If I say it's cloudy outside, that could be a statement that we could validate with it being true or false. I could say 5 plus 7 equals 2, and that could be a statement, and that would obviously be false, but that would be a statement. Each statement will have a truth value, so the truth value would either say is true or false, depending on what the statement is. And when we have different statements, like let's say we have a statement, and I'm going to call that statement P. And instead of writing out the whole statement, then we could just say, okay, statement P. A rectangle has 4 sides. And that would be my statement. What I could do then is I could do the negation of P. The way that that would look is you would probably see like a little squiggle mark with a P. When you negate something, you give it the opposite truth value. So I'll just write opposite truth value. So for this statement P, this negation of this would say that a rectangle does not have 4 sides. Okay, you're going to add in the word no, or maybe the word not, or if something's equal, you might say that it's not equal. Okay, or if the original statement says that something is not, if I say it's not cloudy, when I negate that, I would say that it is cloudy. So you're basically just needing to know that it's going to be the opposite truth value, and that'll be the most important part for this. And also then that the symbol is kind of like a squiggle mark for that. Okay, so some of the questions will be that easy. It'll say, is this statement true or false? But most of the time they're going to have you do a compound statement where you're putting 2 statements together. And those 2 things are a conjunction and a disjunction. And I'm not going to be super picky that you remember which one's which, but you do need to know that conjunction is and you'll need to know more about like what that and statement means. And disjunctions, those are or statements. So looking at these, we might have a statement like, I am a teacher and a mom. And if I say that together, that would be a true statement because it's true that I'm a teacher and it's true that I'm a mom. So that and statement, when you put both of those things together, that would also be true. If I were to tell you that I'm a teacher and an astronaut, that's probably pretty obvious that that is a false statement because I'm not both. So in order for an and statement to be true, you actually have to have both parts true. So I'll just write both parts are true. And there's a symbol for that also. The symbol for an and statement actually looks like a capital A, just without the little like line through it. For or statements for our disjunction, if you reverse that, it kind of looks like a V. Those would be or statements. And I'll write one of those out quick too. If I write, I am a teacher or a doctor. I mean, I'm not a doctor, but since I am a teacher, this or statement would actually still be true. You only need one part to be true for an or statement to be true. So I'll just write only one part has to be true. You could have both parts be true if I say I'm a teacher, or I like to read. Both of those things are true. That would make that a true statement also. Okay, let's do some examples. Okay, so this is the way that these examples will look in your book. They will give you just kind of some general statements like this, and then ask you about the truth value of some different things. So what I always like to do first is I like to just go through and tell if these statements up here are true or false. So the first one, P, 1 foot is 14 inches. Hopefully you know that that is a false statement. So I would go through and just label that that part's false. So then every time you see P, you just know that that's false. Okay, September has 30 days. That is true. Remember that little rhyme, 30 days has September, April, June, and November. And then R, a plane is defined by 3 non-collinear points. And that is also true. So they're going to kind of get you on some of this vocabulary from Chapter 1 with some of these. And then other times they'll just be pretty obvious things like a foot is 14 inches. Okay? So if I'm looking at this first one here, if I want to write it out, it says P and the negation of R. And I'm not going to make you write all this out, but I'll kind of read through what it would be. Really what we want to be doing is just telling if this statement is true or false. So as I read through this would say 1 foot is 14 inches, and the negation of P, a plane, is not defined by 3 non-collinear points. Okay, just kind of abbreviating that quick. So for this one here, I have something that's false, and since this was true, the negation of it's going to be false. If I have 2 false statements, the overall truth value is going to be false. Okay, and again, the directions in the book say to write it out. I'm going to say that as long as you know that this is false, I'll just make you write it out like that. If you have trouble with these, then we might have to go back and relook at like writing out more of that sentence, what that would say. Okay, for this next one, to negate P, I would say that 1 foot is not 14 inches. Okay, and you don't need to change this to make it right. You just say the foot is not. You add in the word no or not equals. Don't try to make it anything different. So 1 foot is not 14 inches, and September has 30 days. So since both of those are true, the overall truth value would be true. And that's the only way that you can get an and statement to be true, is if both parts are true. Okay, for these or statements, remember for or statements, you really only need one or the other to be true. So this first part says not Q. So I'd say that 1 foot is not 14 inches, or, oh, I'm sorry. So for this next part, I would say that it's not Q, so September does not have 30 days. So that's not true anymore. Or P says 1 foot is 14 inches. So when you have 2 false things, the overall truth value is also going to be false. Okay, and then lastly, remember this V thing means a plane is defined by 3 non-collinear points, and or September has 30 days, and that would be true. So we'll work on this stuff together in class if you have questions. I I've put this chart on here. This is just kind of a summary. This is directly out of your book. If you would like to have this stuff kind of written out better, if you want to copy that into your notes, feel free. But I'll just kind of leave it at that. Remember, negation has the opposite value, and then it's the squiggle mark if you need to maybe kind of make that a little bigger, and it's read as not P. A conjunction, when you use the word and it has that symbol that kind of looks like an A, and you read it P and Q. And a disjunction would be that word or. It looks kind of like a V, and you read it P or Q. And what they have here is they have this P and Q, and those are just standing for certain statements. It could be any statement, just kind of whatever those statements are. So we have a lot of different ways that we could have truth values, and we have a way of organizing the different types of truth values. And we can do that in a truth table. Truth tables are always going to start out the same, because if you have two different statements, there's only a few different ways that those statements could be. So let's say I have two statements, and I'll call them P and Q. But this could be Q and R, it could be A and B. They'll use the letters P, Q, and R quite a bit. But these really could be anything. These are just kind of like a variable standing for some different statement. There's only possible values that these could have. Each could both be true. So you could have two true statements. And usually you see those written at the top of the truth table. You could have both of them be false. And usually you see those at the bottom of the truth table. Or you could have one of each. You could have the first one be true and the second one false. Or you could have the first one be false and the second one true. And those are really our only possibilities. There's not like there's any other ways of having statements when you have them be true or false. So the beginning of your truth table will always look like this, with the exception of maybe you have like R and S or any other letters like that. So I'll just write always begin truth tables like this. So maybe we have to make the truth table for P and Q. And if that's the case, what I'm going to do is I'm going to put that here in this third column. So P and Q. And all I'm doing then is looking across and figuring out, okay, if I have two true statements, will the statement P and Q be true? And the answer to that is yes, it will be true. Because remember, and both parts have to be true. So then for the rest of these, if I have a true and a false statement, like I'm a teacher and a doctor, that would be false. If I have a false and a true statement, I'm a doctor and a mom, still false. And if I have two false statements, I'm a doctor and I was on Mars yesterday, that's false too. Okay, so if it's an and truth table, you'll actually have one thing that's true and three things that are false. And the location of these might vary depending on like what truth table we're setting up. So let's do one more together. Let's say I want to have P or the negation of Q. So I'm going to start this truth table out the exact same way as the other one, except now instead of having 3 columns, I need 4, because I need to add in a column for this negation of Q. So I'm going to have P, I'm going to have Q, I need to now negate Q, and then this last one's like my final answer column. So P or the negation of Q. So the beginning starts the same. I have them both be true. I could have the first one true and the second one false. I could have false then true. Or I could have them both be false. Okay, and then what I would do is I would just not worry about this P column at all. I would just look to the negation of Q. To negate means to give it the opposite truth value. So since this was true, this would be false. This is false. That makes this true. True would be false. And then false would be true. Okay, and then this last one, I need P or the negation of Q. You could even like cross that one off if you wanted to, because you don't need that. So if I have a true or a false one, remember if it's or, you only need one part to be true to make it true. If they're both true, this will be true. If they're both false, this will be false. And a false and a true will also be true. So when you have or statements, you'll have 3 true, 1 false. Okay, and then this section, the last thing is looking at some Venn diagrams. I know that you've done Venn diagrams in the past. Some of them will have just the 2 circles. This one here has the 3. So I'll do one that's more complicated with you. So it says a Venn diagram shows the number of students enrolled in Monique's dance school for tap, jazz, ballet classes. So this circle here includes all the kids that do tap. Okay, so it's not just 28 kids that do tap, it's 28 plus 13 plus 9 plus 17. It's all of those kids. So don't let that confuse you, because I know sometimes we look at that and we just say, okay, tap is 28, and you try to move on. Okay, so looking at this, I want to locate the kids that do tap and jazz. So this is the kids that do both. So they have to have like truth values for both of those. So I'm going to find that in this section here. It's where they overlap. It's where they intersect. So the kids that do tap and jazz is going to be the 22 kids that are found in those intersections. So 13 plus 9. Okay, only ballet would be these kids here, because this 17 and this 9 and that 25, those kids do more than just ballet. So the kids that only do ballet are the 29. Okay, where it says here tap or ballet, let me get a different color. So tap or ballet, that includes every kid that does tap and every kid that does ballet. So that actually includes all of these kids, with the exception of these 43 that do jazz. So what I would do is I would add all of those up. I have seen students here, they add up all the kids that do tap and all the kids that do jazz or ballet, and they add those numbers together, but then they're actually counting those twice. So when you add up these numbers here, you should get 121. Okay, and then lastly, the ones that are enrolled in all 3 classes, that would be the intersection of all 3. So that's just this section here in the middle, and that would be 9. I look forward to helping you with this in class. I'm sure you have some questions.